Okay, so today we're going to tackle question 2, part A, part 2. In this question, we need to find all the values of x for which 2 to the negative x plus 3 times 2 to the x is equal to 4. Notice that 2 to the negative x is equal to 2 to the negative 1 times x, which is equal to 2 to the x all raised to the power of negative 1. Therefore, the equation can be rewritten as 2 to the x all raised to the power of negative 1 plus 3 times 2 to the x equals 4. To make the equation easier to manipulate, we'd put a equal 2 to the x to get a to the negative 1 plus 3a equals 4. Simplifying the equation, we can multiply both sides by a to get 1 plus 3a squared equals 4a. Subtracting 4a from both sides, we get 3a squared minus 4a plus 1 is equal to 0. This is a quadratic equation. We can factorize the quadratic expression to get the equation a minus 1 times 3a minus 1 is equal to 0. If the product of two or more real numbers is equal to 0, then at least one of the numbers must be equal to 0. So therefore either a minus 1 is equal to 0 or 3a minus 1 is equal to 0. In the first case, if a minus 1 is equal to 0, then a is equal to 1, which implies 2 to the x is equal to 1, which implies x equals 0, since 2 to the 0 is equal to 1. In the second case, if 3a minus 1 is equal to 0, then a is equal to a third, which implies 2 to the x is equal to a third, which implies x is equal to log base 2 of a third by the definition of logarithms. Before completing the question though, we should check that the values we got do indeed satisfy the equation. So doing that check, when x is equal to 0, putting that into the original equation that we had, we get 2 to the negative 0 plus 3 times 2 to the 0. Now 2 to the negative 0 is the same as 2 to the 0, which is equal to 1. And 3 times 2 to the 0 is equal to 3 times 1. 3 times 1 is 3, so we get 1 plus 3 equals 4, which is the result that we should get. Checking the other solution, when x is equal to log base 2 of a third, we put that into the original equation, and we get 2 to the negative log base 2 of a third plus 3 times 2 to the log base 2 of a third. Looking at the first term, and the exponent of the first term, negative log base 2 of a third is the same as log base 2 of a third raised to the power of negative 1. The inverse of a third is equal to 3, so that's why we get 2 to the log base 2 of 3. And the second term remains the same. Looking at the first term again, 2 to the log base 2 of 3 is equal to 3. And looking at the second term, 3 times 2 raised to the power of log base 2 of a third boils down to 3 times a third. 3 times a third is equal to 1, so we get 3 plus 1 is equal to 4, which is the number we should get if this solution is a solution of the equation. Therefore, we can conclude that x equals 0 or x equal log base 2 of a third are all the solutions of the equation. And that's it. Hey guys, Dwayne here. If you're a Caribbean student struggling with Cape Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching and see you next time.